memory, we noticed that if you double the previous number and add 1, we get the next one. Or we draw on these diagonal lines where this number is 1 less than the number diagonal from it. We remember that? Remember where we are now? Okay. So table 1 came up with 2n minus 1. And it didn't work, did it? But were we close?
Yep.
Okay. So let's try it. Let's remember where we were. If we substitute 1 in, what do we have? 2 to the 0 power, which is 1 minus 1. Let's substitute 2 in. What do we have? Which is 2 minus 1. Let's substitute 3 in. 2 to the second power. 4 minus 1. 3. What do we know? And what did we notice about these numbers? They're shifted, right? We need to get this row and kind of move it up 1. We've got to find a way to make that shift. So Brian, you suggested 2 plus 1, or 2 to the n plus 1 plus 1, right? I'm going to do yours blue. I don't think we did this one yet. Let's see how close we are, okay? Substitute 1 in, and what do we get? 2 to the second power, which is? Plus 1 is? 5. Let's try it again. Let's do the second one. 2 to the third power, which is? Plus 1. Do we like these numbers? No, which one was closer?
Top one.
Alright, so let's play with this top one. Because this one isn't producing numbers we like. So we'll get rid of this 2n plus 1, and so we're left with this one. How else can we change it? What else can we try? Yes?
Divided by 1?
We want to divide by 1 instead of subtract 1?
Yes.
So we want 2n minus 1 divided by 1?
Yes. Well,
What do you say? Well, that's what?
that's just subtracting 2 then from the end.
So it's just subtracting 2 now? Well, let's see. Let's see. Alright. So we substitute 1 in. What do we get?
1. Oh, wait.
0. Substitute 2 in. What do we get? Which is 2 minus 1 is? Are we getting the same numbers? Why? Yes? You know? If I said 8 divided by 1, what does that equal? 8. If I said x divided by 1, x. So does dividing by 1 do anything?
No.
No. Divide by 2?
I would cut everything in half.
So that's going to cut these in half. Good observation. It's just going to cut these numbers in half. Okay?
So you do 2n minus 1 plus 1.
So 2n minus 1 plus 1. We're going to try that? Alright, let's try this now. Substitute 1 in. 2 to the 1 minus 1 is 2 to the 0, which is? Plus 1. Let's try it again. 2 to the 2 minus 1 power is 2 to the first, which is plus 1 is? I don't recognize this pattern, do I? Does anybody recognize this one? So the first pattern is still our closest one. Plus 1 didn't work. So we keep changing that plus 1, minus 1. What else could we change? What else could we change? Yes.
2n minus 1.
Just leave it as 2n minus 1?
No, not like n minus 2n.
So 2, is it 2n? How do we say that? 2 to the power of n, because 2n sounds like 2 times n. 2 to the power of n minus 1. You seem pretty confident. Did you try it?
No, but that's one that I kind of thought it was.
Alright, let's see. We substitute 1 in. 2 to the first power. 2 minus 1 is? Oh, we're on the right track. We got got the first one. Let's try the second one. 2 squared minus 1 is? Oh.
Maybe it would.
Now what?
Now we keep track.
You're right. We got to do more than 2. 2 to the third power minus 1. Are we convinced? We're convinced. You're not convinced? You want to do one more? All right. So 2 to the n minus 1, we finally have our equation. And this equation tells us what again? On that square, total, after that many squares. So let's figure out, for fun, after 64 squares or 64 days, how much money is a total? So using our equation, how are we going to figure that out? What should we do? We have this equation, and I want to know what is the total after 64 squares. What do I do? Maisie, do you know? What do you do before you tell me the answer?
Put 2 before n and you insert 64 and 10.
So 2 to the 64,
And
then
then you subtract 1.
minus 1. What do we get? What does it say? Yes?